Today we are talking about exponential functions. First time you are looking at exponential functions in pre-AP Algebra 2. We have to look at the two different functions that are explained by f of x is equal to b to the power of x when b is greater than 1. That means the base is greater than 1. The second second function is f of x is equal to b to the power of x, where b is between 0 and 1. So these are the only two possibilities for any base of this type of problems. You cannot have a 0 or a negative number to replace b. So if b is greater than 1, this will become an increasing function. So if b is 2, 5, 10, you can choose any value that will give you an increasing function. If you choose a value that is between 0 and 1, that will give you a decreasing function. So that is all about exponential functions. When we look at the transformations, so you need to understand this is the transformational form of an exponential function. That is, f of x is equal to a times, that's times, b to the power of b times x minus c, then plus d. A is the reflection over the x-axis, or you can also say it's vertical stretch or compression. The capital B is the base, and the small b is a reflection over the y-axis or horizontal stretch or compression. The C over here is the horizontal shift, left or right, depending on the sign. And the D is the vertical shift, up or down, depending on the sign. So these are the four important components of a transformational form of an exponential equation, exponential function. So one more time, the base, if the base is greater than 1, this is an increasing function. If the base is between 0 and 1, that is a decreasing function. Let's look at an example. F of x is equal to 2 to the power of x, and we already know the base is 2. 2 is greater than 1, so that means this function is going to be a growth, and you can see that it's over here, but I'm going to help you with how to graph this one by step. Start from we will get these attributes later, and before we do that, we will just look at the parent points and we will graph the function. So the parent points, normally we will be using 4 sets of points. First one is -1, second one is 0, 1, and 2. That's more than enough for graphing an exponential function, unless it is another complicated function or a different type of function where you need more points to be plotted. So, and we know that our function is this is our parent function. We can create several parent functions by setting the base as a number, which we talked about. The two different criteria. One is the base greater than 1, and the other one is between 0 and 1. So we set the base as 2, that's 2 to the power of x. That's what we're graphing today. So we know that this is y is equal to 2 to the power of x, and -1 is x is replaced by -1, so 2 to the power of -1, which is 1/2, and 2 to the power of 0, which is 1, 2 to the power of 1 is 2, and 2 to the power of 2 is equal to 4. Let's plot these points. So for x equal to -1, the y is 1/2. For x is equal to 0, the y is 1, which is actually the y-intercept. 1, 2, and 2, 4. 2, 1, 2, 3, 4. So we have the numbers plotted here, and we can just graph this, and that is going to be the function that we are looking for. So this is y is equal to 2 to the power of x. Couple of things you need to understand. This is an increasing function, and this has an y-intercept. This has no x-intercept. The function approaches this line, which is actually the x-axis, as x takes smaller and smaller values. So basically The x-axis is the horizontal asymptote. It doesn't have a vertical asymptote, it just has a horizontal asymptote, and that is y equal to 0. So we have that things in here. So when x takes smaller and smaller values, the curve approaches to this line. So this line is the asymptote, the horizontal asymptote, which is x-axis or y equal to 0. Let's look at the attributes. The domain of the function is definitely negative infinity to positive infinity because it extends to both sides. Range is the function starts just above the x-axis, so it is starting from 0 all the way up to positive infinity. X-intercept is there is no x-intercept. The curve never ever crosses the asymptote, so there is no x-intercept. Y-intercept is 0, 1. We can find that over here. Asymptote is y equal to 0, which is the x-axis right here, and this function is increasing function, and that's all about y is equal to 2 to the power of x. Let's talk about this function f of x is equal to e to the power of x. The e stands for Euler, and that has a value as approximately 2.718, etc. So we are using these values for our calculations right here. So since e is greater than 1, definitely this function is going to be an increasing function. Let's quickly make a table, then come back to the attributes. So the first thing, we will have to use the same values that we used before, negative 1, 0, 1, and 2, and y is equal to e to the power of x, and it is going to be e to the power of negative 1 over e. Second one is e to the power of 0, which is going to be 1, then e to the power of 1, that is equal to e to the power of 2, that is equal to e squared. You can use a calculator to find these values. Of 1 over e is approximately 0.37. That is 1. E is 2 is approximately 2.718, and e squared is approximately equal to 7.4. You can just put it as in the 1 decimal place, which is 2.72, or just doesn't matter. Okay, let's plot these points to look at the graph, and negative 1 and 0.37, negative 1 and 0.37, somewhere close to this one over here. 0, 1, the same y-intercept like we did before. The 1 and 2.7, 1 and 1 to 2.7 is somewhere close to 7.2, it doesn't matter. And 2 is 7.4, 1, 2, 3, 4, 5, 6, 7, 7.4 should be close to this point. So that is going to be the points, and that is graphed. And that is going to be our graph for this example right here. So this is the exponential function for y is equal to e to the power of x, and that is an increasing function. And let's look at the attributes like we did before. Domain is negative infinity to positive infinity. Range is 0 to infinity because we know that the asymptote is right here. Y-intercept is there is no y-intercept. X-intercept is there is no x-intercept, there is a y-intercept, which is 0, 1. Asymptote is the x-axis or y equal to 0, and it is an increasing function.